Dear students and participants of the course on railway engineering, today we are going to talk about the crossings and the turnout design. In the previous lecture, we started discussing about the points and crossings, and there our focus was on the various components. Like we have discussed about the tongue rails, we have talked about the switches, and then towards the end we started discussing about the crossings. Now in today's lecture, we will be discussing about the one terminology which is used with the crossings, that is number of crossings. And then we will move into the design of the turnouts. There are three methods: the Coles method, there is one alternate method available so as to design the turnout, and the last one is the Indian Railways Standards method, IRS method. So we will go through all of these three methods one by one. Starting with the number of crossing. Now if you remember, we have talked about a crossing wherein the angle alpha was talked. This was angle of crossing, and it got created because we had a point rail and a splice rail. They were meeting at this point. Now this number of crossing, this is correlated with the angle of crossing, and that number basically is used so as to define the type of the turnout. So it is designated by the angle of the gauge face which makes with each other. So this is the angle of the gauge faces are making with each other at this point. If you remember, if I extend the things here, then it will go into this form. So a wing rail will be there. Similarly, this is going to be extended in the other way. So this is the crossing which we have discussed previously. It can be defined as the ratio of the spread at the lag of the crossing and the length of the crossing from the TNC. Now what is TNC? TNC and ANC, these are the two terminologies which we have discussed. So if this is a blunt edge, so here if it is blunt one, then this is ANC, but if it is being taken to a point, then that was TNC. So what it says is defined as the ratio of a spread at the leg of crossing and the length of crossing from the TNC. So this is a TNC value. So if I create here, so whatever is the length of crossing is, with respect to that length of crossing, we are considering the spread. So the spread is going in this form, and obviously this spread will make an angle. Now the alternate method is to designate it as the number of crossing which is represented by n. So we also say that it is 1 in n turnout, and this n may have different values. They are designated values which are being used on Indian Railways. Say there can be 8.5, 12, 16, 20. These are the usual values which are being used. Now what are the three methods with the help of which we can correlate n and angle alpha? The first one is a center line method. Now this center line method is used in UK and USA. It is not being mainly used in India. Now what you can see on the right hand side, a diagram is being created. So you can have a spread being going in this form, and then that is where the alpha angle is being created here at the crossing. We take a center line of this angle, and this is starting from TNC and going up to the total length. So at this level we assume that this is a unit distance. Now if we have moved away from the crossing from the TNC and we get a unit distance, then whatever this spread is coming, that is defined as n. Considering this, if we go by the geometrics, then what it comes out to be? It will be alpha by 2 here, and in that case this will become 0.5. So it is cot alpha by 2 is equals to n divided by 0.5, or n is equals to 1 by 2 of cot of alpha by 2. So we know the angle, so we can find out the number of crossing. The other method is a right angle method, which is used on Indian Railways. It is also known as the Coles method. We will find that there is the design procedure which has been given by Coles, and this is being used on Indian Railways too. So, here the approach is a bit different. What it says that the angle which is being created here, its triangle is a right angle triangle, where for 1 unit distance of a spread, the length which is being moved is n. So, on the basis of that, the formula comes out to be cot alpha is equals to n divided by 1, or n is equals to cot alpha. So, this method, out of the 3 methods, it usually gives you the smallest angle. So, if you are talking about if n is being given to you and you are comparing this n with respect to the center line method or isosceles triangle method or right angle triangle method, you will find that alpha is coming out to be lower in the right angle method. The third one is the isosceles triangles method. Now, in this again the spread is being considered with an angle of alpha, and for a unit spread we assume that both of these lines they have the same value. So, they are all equal to n, and based on this particular value or this particular concept, then we try to find out the relationship. So, when we are trying to find out relationship going by the symmetry and taking this as again an alpha by 2, and obviously the spread here will be 0.5. So, considering that, we come across this particular formula, that is n is equals to 1 by 2 into cosec alpha by 2. So, in all of these cases the alpha is known to us, which is the angle of the crossing, and we can very easily calculate the value of n. Now, this particular method is usually used in the laying of tramways. Let us look at a numerical here. We have been given the angle of crossing, which is 4 degrees 45 minutes and 49 seconds. We have to calculate the number of crossing, that is n. So, alpha is given here. Now, it is being converted into degrees. So, it is 4.7636 degrees. Now, there are 3 methods which we have discussed already. Method 1 center line, method 2 right angle method, and method 3 is the isosceles triangle method. Using the formula which has been given for these respective methods, what we need to do is to only put the value of alpha here. Now, if we put the alpha value here, what we get is 12.02 in the case of first method, exact 12 in the case of second method, and 12.03 in the case of third method. So, basically in this case the number of crossing is 12, or it can be defined as 1 in 12. Now, let us have another numerical here. Here the number of crossing is being defined as 1 in 20, that is it is 1 in n. So, what it says is n is equals to 20. Now, we have to calculate the angle of crossing. So, it is a reverse procedure now. Again we have the 3 methods. We will simply transforming it into the form of alpha versus the variable for which the value is being known to us. So, what we get is cot of alpha 1 by 2 is 2n, cot of alpha 2 is equals to n, and cosec of alpha 3 by 2 is equals to 2n. So, these 3 formula we are going to use now. Now, alpha is to be found out, n is being given to us. So, we just put the values in these 3 equations. What we get is alpha 1, alpha 2 and alpha 3. They can be presented as degrees or they can be presented as degree, minutes and seconds format. So, the angle of crossing which comes here is 2 degrees 51 minutes and 45 seconds. Now, if we see this one, this is the value basically related to the second method, which is a right angled method or a Coles method, which is used on Indian Railways. Now, the use of different type of crossings, as I said that the n value can be 8.5, 12, 16 or 20. So, 8.5 is usually used in station yards or sharp turnouts, 1 in 12 on station yards of main lines or flat turnouts, 1 in 16 on high speed turnouts, and 1 in 20 on further high speed turnouts. So, as the number increases, the speeds are going to be increased. Now, here there are some standard details. When we talk about a standard details, means we are talking about the type of the turnout which is being defined by the number of the crossing, and then on the basis of that what can be the crossing angle and what is the possibility of having a switch angle there. And based on this crossing angle and switch angle, the ease of taking a turn on the turnout is going to be ascertained, and that is where the permissible speeds becomes one important aspect which needs to be taken into consideration. So, if we consider the first one, which is 1 in 8.5, obviously n becomes equals to 8.5. So, crossing number is 8.5. For that, if you convert it to the values into an alpha, what we get is 6 degrees 42 minutes and 35 seconds. Now, there are two possibilities of having a switch angle. One is a bit larger, that is 1 degrees 34 minutes and 37 seconds, but other one is 0 degrees 27 minutes and 35 seconds. So, this second one is usually used on a bit higher speeds. So, you can see the change. In the case of the first one, we have two speeds, that is 10 kilometers per hour or 15 kilometers per hour. Okay, that value is not being written here. So, the unit is kilometers per hour. So, 10 is for the straight switch and 15 is for a curved switch, but in the case of a higher value of the switch angle, we can have 30 kilometers per hour for the straight as well as the curved switch. Now, if we increase the turnout size, if we increase the crossing number, that is from 8.5 to 12, and for that obviously the crossing angle will also change. But if we again consider two conditions with respect to the switch angles, and one of the switch angle, as you can see, is same here, that is 0, 27, 35. So, in the previous case when it was 1 in 8.5, the speed was restricted to 30, but here now it has moved to 40 kilometers per hour for the curved switch. That means there is an increase. So, as the number is increasing, we have discussed previously also that the speed will keep increasing. Similarly, if we talk about 1 in 16, 1 in 20 and 1 in 24 for the n values of 16, 20, 24 respectively, there will be crossing angles alpha 1, alpha 2 and alpha 3, which we can calculate based on the formula, and we will use the IRS formula, the Coles formula, for finding out these values. So, you can try by yourself and see whether you are getting this formula or whether you are getting this angle or not. And the switch angles, they are being defined as 0, 24, 27 in the case of 16 as well as in the case of 20. But here again, if you compare it with 1 in 12, in the case of 1 in 12 we had 0, 27, 35. So, not much difference is there between these two switch angles, but the change is tremendous in the case of the permissible speed. And if you go to n is equals to 24, with a switch angle of 0, 10, 0, 0, then in that case there is a possibility of going to a very high speed of 100 kilometers per hour also. So, this is the beauty of a change of the crossing number or increase in the crossing number. And nowadays we are aspiring to have high speed tracks. We are aspiring to have the tracks where the trains may be moving at a speed of 160 kilometers per hour or 200 or more than 200 kilometers per hour. So, that is where we have to see that what are the types of turnouts which can be used, so that that becomes possible. Now, coming to the Coles method. Now, this method is used for designing a turnout which takes off from a straight track. Now, what is the ideology here is being defined as a second point. What it says, the curvature starts at a point on a straight track ahead of the toe of the switch and ends at the theoretical nose of the crossing. Say if we see in the diagram being given on the right hand side. So, on the right hand side, the T and C is here. This is the crossing. There is a crossing angle alpha is being shown. So, this is a theoretical nose of crossing, and then it says it starts at a point on a straight track ahead of the toe of the switch. So, the toe of the switch will be here. So, just ahead of this, this is starting. So, this is a T point, the tangential point here. And the heel of the switch is located at a point where the offset of the curve is equal to the heel divergence. We discussed about the heel divergence, we discussed about the value which should be there in terms of the heel divergence. If I am correct, we talked about 44 mm. So, what we do is we keep moving along the main track as well as the curved condition, and a point will come where we will get the distance equals to heel divergence. So, that distance here, say Lm, is a heel divergence. So, this is the heel of the switch, yeah, here. Then theoretically there shall not be any kink if the tongue rail is curved, but what happens is the tongue rail may not be curved. So, in this section where the tongue rail is provided, it may be a straight one. So, if it is a straight one, then there are going to be different kinks. Now, what can be the possibilities of the kinks? There are kink here at this point, or if it is a straight one, then the kink will also come here. And thirdly, because afterwards it is becoming straight and up to this it is a curved section, there is a possibility of kink at this location. So, if we talk about these three kinks, which says one at the actual toe of the switch, second at the heel of the switch, and third at the first distance block of the crossing. So, this is what I have shown already in that diagram. Now, when we have to go into the computations of the different components of turnout, so we need to go for a curve lead, radius of curve, the switch lead, the lead of the crossing, and the heel divergence. So, these are the things which needs to be computed. So, let us see how these can be computed. So, here if you see that we are starting the curve from here, that is the point where the heel divergence is provided. So, up to the point from T to L, this is a switch lead. So, the switch lead SL is TL. Now, from there we are moving towards the TNC. So, this is TNC here. So, from this point to this point it is a lead. So, it is basically L E dash. So, if we talk about the lead, so it is L E dash here. And the curve is starting, being assumed to be starting from T and going up to E. So, that means that is a total distance which is there, which can be AE or TE dash, and this is defined as a curve lead. So, curve lead is AE or TE dash in this case. Now, this is the gauge G. So, if you talk about E dash E or you talk about A or T, then that is the gauge of the track. Angle alpha is known. So, on the basis of that angle alpha, we can find out the number of crossing also, and going by the Coul's method or the right angle triangle method, which is used on Indian Railways, it is n is equals to cot alpha. So, that is being taken here. Now, if we talk about the heel divergence at the heel of the switch, this is Lm. So, heel divergence is usually defined by small d, and this is Lm here. And another thing is the curve radius. So, curve radius is from 0 to T or 0 to E. So, that is R is equals to OE is equals to OT. So, now once we have identified that what are the various distances which needs to be considered so as to compute the components of this turnout, let us move forward and see that how this can be done. So, let us starting with the curve lead CL. Now, the curve lead CL which is this total one, that is AE or TE dash. So, that is AE or TE dash, which we have already identified. So, looking at the triangle ATE. So, where is A? This is A, this is T, and this is E. The angle is alpha. So, here this angle, because we are taking a bisector here, so it becomes alpha by 2. So, ATE, if we consider, so AE is nothing but AT cot alpha by 2. So, AT is this, and this AT is again the gauge. So, it is G cot alpha by 2. Alternatively, if we talk about in terms of TE dash, then for TE dash it will be TC plus CE dash. So, it is TC plus CE dash, as if you see here in the diagram. Now, we can calculate the value of TC and CE dash. Now, TC, if we look at the triangle TCE, so in the case of this triangle, and there is another triangle which we will be considering is CE dash E. These are the two triangles which we will talk here. Now, this TC and CE, they will be equal based, that is on the basis of the geometry of this triangle. So, TC is equals to CE. And if you are talking about CEE dash and you have to calculate CE, the angle of crossing here, now this angle becomes again alpha. So, and we know that EE dash is G. So, considering that, what we finally get is that this TC is G cosec alpha, and CE dash, that is G cot alpha. So, if we take these two together, then we will get a value of G cosec alpha plus G cot alpha. Now, if we consider this value that n is being defined as cot alpha, which is on the basis of right angle triangle, then the CL will be transformed into this equation, that is G into 1 under root of 1 plus n square plus G into n. Now, here, now this 1 plus n square, further we can see that 1 plus n square is roughly equals to n square. So, considering that, what happens is that this was under root of n square. So, this is G into n and plus Gn. So, we can also write approximately that CL is going to be equals to 2Gn. Now, the second value which we are looking here is SL. So, that is the switch lead, and this switch lead is actually up to the heel. So, this is TL. So, this TL we are considering, and for considering this TL, then we can consider the triangle TLM. So, when we are considering this triangle TLM, LM is small d, and we go with the angles. So, considering here what we will get on the basis of again the geometry of the triangle, that SL into SL is equals to D into 2R minus D, and finally, SL is nothing but under root of the difference between 2RD and D square. So, this is another equation which we will be using for calculations. Then comes the curve lead, and the curve lead is LE dash. So, that LE dash is basically, or otherwise the other way also is there, because you have already calculated CL, you have calculated SL. So, the difference between the CL and SL is going to be the lead. So, whatever value, whatever these equations which we have found here, they can be used directly, and we can get G into cot alpha by 2 minus under root of 2 RD minus D square. The last component which is required is R, and of course, this D also, which is LM is equals to D. This can also be transformed into the values of the normal variables which are available to us in this case. So, first of all, let us look at the radius of curve R. This radius of curve R, if we are talking about a triangle AOE, so this is A, and this O will come somewhere here, and this E. So, this is a triangle which we are looking at. Angle alpha is there, and here it will be 90-degree condition. So, this R is nothing but R is OE, or this is equals to OT. So, OE, because we are talking about the outer rail. So, this is a radius is up to outer rail. So, it is OT or OE, and then this OT is nothing but this is OA plus AT. So, OA plus AT, where AT is known to us, AT is simply the gauge. So, OA is to be identified, and just to find it, identify OA, how we calculate? OA is nothing but because OT is the total radius and AT is G. So, it becomes R minus G. Now, if we consider this triangle and we take this triangle OAE, so OE square is equals to OA square plus AE square, and AE is nothing but it is a curve lead, and OA we have already found out, this is R minus G. So, R minus G whole square plus CL square. So, when we solve this, what we get is R is equals to 1.5 G plus 2 G n square. So, this is the formula. You know the value of n because angle alpha is known to you, G is already known because the type of the track is known. So, we can calculate easily the value of R. And lastly, the value of D can be calculated, which was nothing but LM, and this is given by SL square divided by 2 into R plus G by 2. This is again from the geometry of the triangle. Now, let us look at one of the numerical here. So, here it says that we have a broad gauge track, that means G is being defined as 1.676, and there is a turnout of 1 in 8.5, that means N is defined as 8.5, and considering this N 8.5 and the Cole's method or right angle triangle method, if we say that is N is equals to cot of alpha, we can find out the value of alpha. And in this case another value which is given is that take the heel divergence as 120 mm. So, this is a small d. So, small d is 120 mm already given to us. So, it means we are not calculating that. So, once we have these values, the curve lead is being defined as CL is equals to G into under root of 1 plus n square plus Gn, or we said that it is going to be 2 Gn in an approximation manner, because 1 plus n square can be taken as equals to n square 2. So, if we go with that, so G is 1.676, n is 8.5, we put these values here and what we get is 28.6 meters. Then the radius is defined by 1.5 G plus 2 Gn square. So, again if we put the values here, what we get is 245 meters. Switch lead, it is under root of 2 R d minus d square, d is already given to us. If it has not been given to us, we would have calculated that value and we will put it here. So, here this is 2 R d minus d means 2 R and d, which was 120 mm minus d square. So, 7.67 meter is the value. The curve lead is found out, the switch lead is found out. Now, the lead is nothing but the difference between the two, and the difference comes out to be 20.93 meters. It means now we have all the elements which are required so as to trace this turnout, and then it can be done easily in the field. Let us talk about the alternate method. Now, this alternate method says the assumption is the curve is tangential to the tongue rail. That means the tongue rail is coming straight here, and from this point the curve is starting and it is going up to the TNC. So, it ends at the TNC. So, it is starting at the heel, it is ending at the TNC. Previously, we assumed that it was starting at the tangential point somewhere here. So, that is the difference between the two methods. So, in this case what will happen, how many kinks are going to be created? One kink is at TNC and one will be at the heel. So, here that tangential condition will be there. So, we have two kinks, one at the because the tangential has been created. So, it will not be there, but here in the case of the tongue rail which is meeting the stock rail here, now the one kink will be at this point. Now, on the basis of this, now we are left with to identify only distance between these 2 points, and that is defined as the crossing lead. Now, here when we have to find out this particular lead, now this distance is already known to us, this is G. So, let us talk about a triangle which is T, C and D. So, this is T, this is C and this is D. So, if we are considering this triangle, the total angle is alpha and the switch angle is beta. Here this is the switch angle beta. So, considering this, the angle of crossing and the switch angle, if we go by the again the geometry, what we are going to get is the angle which is TCD. So, this is TCD, then that value is coming as alpha plus beta by 2. So, the lead L is CD. So, this is a CD. Now, this can be nothing but TD, that is from here to here, TD into cot of angle. So, when we are working this TD into cot of alpha, TD is nothing, TD is what? Here total gauge is G. So, from this point to this point it is G, but at this there is a heel and that is where there will be a heel divergence. So, when there is a heel divergence, that will be reduced from it. So, it is G minus D. Considering this, what we will get is L is equals to G minus D into cot of alpha plus beta by 2, and that is how the calculation can be done. So, G is the gauge of the track, D is the heel divergence, alpha is the angle of crossing and beta is the angle of switch. And the radius of the central curve, that is R. So, if we are talking about this central line and if we are considering the radius for this one, then this is nothing but the R naught, which is the radius of the outer rail on turnout. So, from that half of the G is being removed. So, that will be the radius of the central curve. Now, this R naught in that form, if you calculate, so this R naught is OC and that is equals to O T. So, if we go by that, this is R naught is OC here or OT here, and that the heel we have calculated that this TD is G minus D. So, going by again the geometry here, what we can find out is R naught can be also calculated by this formula, which is G minus D divided by the difference of cos of beta and cos of alpha, where beta is the switch angle and alpha is the crossing angle. So, let us look at numerical with respect to what we have discussed. So, it is a broad gauge track 1.676 meters of G. Heel divergence small d is 120 mm, angle of crossing alpha is 334.35 and the switch angle beta is 0.2427. So, these values are being given to us. We have to calculate the lead of the turnout as well as the radius considering the alternate method. The other way of writing that can be consider that the curve starts at the heel of the switch and ends at the TNC. So, if this is written as a line, in that case again you will be using the alternate method. So, here these values are known to us. So, we have first of all written what is given to us, then the lead is G minus D into cot of alpha plus beta by 2. So, G 1.676, D is 0.12, alpha and beta values have been placed here. So, when we place all of these values, we get L as 44.74 meters. Similarly, for calculating R naught, the equation is available to us, which is G minus D divided by cos of beta minus cos of alpha. So, again if we put the values here of G, D, beta and alpha and calculate, what we get R naught is 818.95 meters. So, the radius of the central line on the turnout is nothing but G minus 2 is to be reduced from it, and if we reduce that G minus 2, that is 1.676 divided by 2, we get 818.112 meters as that value. So, here this is basically RC. Now, coming to the another method, which is IRS method. Now, this is a standard layout method being used on Indian Railways. Here the assumption, in all the three cases the assumptions are different, that is the basic catch, that which particular method you have to use. So, here it says curvature starts from the heel of the switch, the same condition as the previous one. So, the heel of the switch is here, that is AB is the heel divergence. So, it is starting from here. Now, previously we said it is ending at TNC. So, TNC was at this point, but now what it says? It says it ends at a distance ahead of the toe of the crossing. That means this is the toe of the crossing, at some distance ahead this curve is stopping. So, this distance h is known to us. So, as soon as in your numerical this value of h is being given to you, it means you have to work with IRS method, or otherwise it may say that the curve is starting at the heel of the switch and is ending at a distance ahead of the TNC, then also this IRS method will be used. Now, crossing is straight and hence no kink is experienced at this point. Now, everything is getting tangential, only kink which is coming is at the toe of the switch. So, here where the tongue rail is meeting with the stock rail, at that point one kink is still being left. Now, calculations in this case are a bit difficult and we will see that what type of formula we are going to get in this. Okay, so, it is a bit difficult to remember those things. Now, in this method the lead of the crossing and the radius of the turnout curve, these two things are calculated. So, let us calculate that. How to do that is, now the lead of the crossing is basically from D to P, that is the point up to which the curve is there and from where the curve is starting. And this, if we say this is dP, so it is also equals to CH. So, that is the lead. Now, the distance between the two lead rails, that is A and D, is G, that is the gauge of the track. Then at this heel AB is nothing but the heel divergence D, so that is small d, and HE is the distance before ahead of the T and C. So, this is T and C at which the curve is stopping. So, that is given by small h. So, that is a small h. Now, if we talk about say BC, so this BC here, this BC is nothing but it is BD minus CD, and BD is how much? BD is at this point BD can also be written as AD minus AB. So, AD is known to us, AD is G, and AB is the heel divergence, so it is small d, so it is G minus D. And the CD is also equals to HP. So, if we come here, this is an angle alpha, so obviously this also is an angle alpha, and this H distance is known to us, so we can very easily calculate what is HP. So, the lead of the crossing L is dP is equals to CH. So, this is dP and this dP is equals to CH, and CH can be now worked with respect to the triangle, that is BCH. So, if we go into the BCH triangle and talk about that angle CHB, then this angle CHB comes out to be alpha plus beta by 2. Okay, you can also try by yourself that how these are coming. So, we calculate CH is BC into cot of alpha plus beta by 2, and then BC is already we have calculated at the back. So, BC was basically BD minus CD. So, it is G minus D minus H sin alpha. So, it is G minus D minus H sin alpha into cot of alpha plus beta by 2. And the total lead from the T and C, if we say that how much is the distance from the T and C, if we are talking, then this H cos alpha is also get added. So, this H cos alpha is being added. So, we will get this total lead. Radius of curve R, this is nothing but OB or OH. So, this OB and OH we have to look at. So, in the triangle OBH, if we consider this, now the angle here will be alpha minus beta, that is a difference between the crossing angle and the switch angle. So, going by that, BH comes out to be 2R sin alpha minus beta by 2, and again if we go into the triangle BHC for finding out BC in terms of the other values. So, what we get is BH into sin alpha plus beta by 2, and BH is already written here. So, finally, the value of R comes out to be G minus D minus H sin alpha divided by cos of beta minus cos alpha. So, we can now in that form calculate lead, total lead and the radius using IRS method. So, we close our discussion now. What we discussed about the number of crossings. We talked about the three methods by way of which we can find out that number of crossing, correlating it with the angle of crossing. Then we started discussing about the methods which are available to design a turnout. So, there are three methods: Cool's method, alternate method and IRS method, and we have looked at some of the numericals related to that. So, we are closing now. Thank you. We will be meeting in the next lecture.